Okay, we are going to create a test bench to test our inverter design. So I created a test bench library. Now we'll create a new cell view. Let's name it Inverter Testbench Schematic. All right. So we're going to put our inverter symbol that we created before. So let's add instance, and here's our inverter library, and this is our inverter. Now we are going to bias the inverter, so let's put a VDC voltage source. That's DC voltage source. We are going to use it for DC bias as well, so let's put it here. Now we are going to put a VDD here, and we need a ground. Let's put a couple of grounds. Now for transient analysis, we will need a V pulse. So let's go here and put a V pulse. Let's put it here. Now we are going to put a capacitor at the output. Let's put it here. Now we are going to connect them with a wire. Just press W and you can start connecting using a wire with different components. So we just connected them. Pretty good. Now we need to change the parameters for each of the components. So let's change the voltage. Let's put it as 1.1 volt DC bias, and for DC analysis let's also put 1.1 volt as input, and for DC analysis we are going to keep the V pulse 0 volt. And let's change the capacitor, and let's just put as out cap as a capacitor parameter, so we can change it when we do the analysis. So let's start the DC analysis. So we are going to check and save. No errors. Now let's go to launch. ADEL. So here we can change the temperature of the device simulation. So now it's at 27, that's room temperature. Sounds good. So you can copy the design variables from the cell view. Let's copy it. So one of them we need to set it. Let's set it as 1 pico. Let's go put some pins in here. Let's put the input pin right here, and let's put an output pin right here. Now let's go back here and let's set the output from the design, and let's select this NAT and this NAT, and go back here, press OK. Now, so that we can sweep VDC, we need to import from here. Let's set it as 1.1, just a random value, because we are going to use that value later. So let's go here, DC design variable, and let's select the VDC. Okay, let's sweep it from 0 to 1.1. It's okay. Now I can run it. So here is the DC analysis output. As you can see, there is a linear change of the input voltage, and when there is a switching at the output, we can see it the output is switching from 1.1 to 0 at this point, where VDC is close to, it's like 50% of our maximum value, that's 1.1. So it's around 500 millivolts.